A very good morning, students. Let us see about encoders and types of encoders now. We know encoder is a device which is used to convert input information into a code. A device which is used to convert input data or input information into a code is called as an encoder. So this encoder is widely used in data compression and signal processing, and it plays a very crucial role in converting data to a code. There are four types of encoder. In the last three videos, we have seen 4 by 2 encoder, octal to binary encoder, decimal to BCD encoder. In this video, we are going to see about the priority encoder. The one point that we need to remember in encoder is at any point of time, only one input will be high or active, rest will be zeros. So that is the basic concept behind the encoder. At any point of time, only one input will be high. So let us see about the priority encoder. In priority encoder, if by chance, if multiple inputs are high at a time, what is to be done? Then we need to go for priority encoder. In all these three types of encoder, 4 by 2 encoder or 8 by 3 encoder or 10 by 4 encoder, at any point of time only one input was high, whereas in priority encoder is used to tackle a situation if by chance if multiple inputs are high. What is the type of encoder we are going to use? Priority encoder. Priority encoder is similar to that of an encoder where you have 2 power n inputs and n outputs. So this is an example for priority encoder where I have 4 inputs and 2 outputs. 2 power n inputs, n outputs. So it produces output code based on the highest priority. We'll see this now. So priority in encoder gives priority to the inputs. Suppose there are 4 inputs, D0, D1, D2, D3. It gives priority or assigns priority to the inputs. Here D3 is given the highest priority. Next level of priority is given to D2. Next priority is D1 and next priority is D0. So now we understand that priority encoder is similar to that of encoder, which is majorly used to tackle the situation where we have multiple inputs are high. So priority encoder assigns priority to the inputs. In this case, we have assigned D3 as the highest input, D0 is the lowest input. Okay. Now let us see the circuit truth table. How many inputs we have? We have 4 inputs D0, D1, D2, D3 and 2 outputs X and Y. So draw the truth table D0, D1, D2, D3 and 2 outputs X and Y. I have written a bit called valid. V stands for valid. If all the 4 inputs are 0, is it valid? No, it is not valid. So what output will be a don't care output. Okay. So 0 indicates it's not valid. When priority encoder will be valid? When an encoder will be valid? When any of the inputs must be high. So in the first 3 types of encoder, only one input should be high. Whereas in priority encoder, we'll tackle a situation that if there are multiple inputs are high. So let us see this case. In this case, first D0 will be high and rest will be zeros. So what is that we do? Since it is D0, we write 0, 0, 0. D0 is high. D0 is high. So we write 0, 0. Since any one of the input is high, we write this is a valid condition. Okay. See the next condition. D1 must be given the highest priority. I don't mind D0 is 0 or 1. Whether it is 0 or 1, I give priority only to D1 because D1 is higher priority than D0. So it is 1. So I write here output as 1 and 0 and 1 representing D1 and it's a valid. So I write it as a valid. If D2 is 1, and D1 and D2, D0 are don't care. So what is don't care? It can be either 0 or 1. I don't mind whether D0 is 0 or 1 or D1 is 0 or 1. If I find D2 is 1, my output is 2. So it is 1, 0. Next, D3 is 1. I don't mind whether D2, D1, D0, 0 or 1. I give my output only for D3. So I write it as 1, 1. Okay. So V stands for valid bit. When it is valid, when any of the inputs are high, only then it is valid. If none of the inputs are high, then it is invalid situation. So my output will be don't case. Okay. Let us draw the let us see the equation for x and equation for y. You can either call it as equation or you can call it as logical expression. So x, when it is high for D2 and it is high for D3. So I need to write this expression. X is equal to, it is high for D2 and can you see here, this is 1 and this is 0. So D2, D3 bar. D2, D3 bar plus, can you see here, it is high here, so it is D3, D3. So shall I repeat? X variable is high for these two positions. Go to the first position and see its corresponding inputs D2 and D3 bar. D2 and D3 bar plus, see this corresponding input position D3 plus D3. Apply distributive law. Take this as a term, this as a term, apply distributive law. D2 plus D3, D3 plus D3, D2 plus D3, D3 bar plus D3. Okay, you know A bar plus A is nothing but 1. So my X is D2 plus D3. Are we done with X? Now we need to find the logical expression for Y. So logical expression for Y is, come and look here, you have 1 here. Find its corresponding inputs. So D1, D2 bar, D3 bar, D1, D2 bar, D3 bar plus, you have 1 at this position also. See its corresponding inputs D3. So D1, for this one, it is D1, D2 bar, D3 bar plus D3. Now again, apply the same distributive law. Treat this as a single term. D1, D2 bar as a single term. D3 bar plus D3. Can you understand? Treat this as a single term. So if you treat this, what is that you write? You write D2 plus D3, then D3 bar plus D3, right? Similarly, treat this as a single term. D1, D2 bar plus D3, D3 bar plus D3. You know A bar plus A is 1. So D3 bar plus D3 is 1. What is the answer you get? Y is equal to D1, D2 bar plus D3. So I got the expression for X. I got the expression for Y. Now what is that I am going to do? I am going to draw the logic diagram. So how many inputs I have in priority encoder? D0, D1, D2, D3. So D0, D1, D2, D3. What is my X? D2 plus D3. So I take my D2 wire, I take my D3 wire. Since it is plus, I use OR gate and write my X. Now how will I write my Y? Draw my Y. Y is D1, D2 bar. So D1, D2 complement D2 bar. Put it in a AND gate because it is a product term. Put it in a AND gate. That output is given to the input of an OR gate and D3. So for this plus term, I am using OR gate. This is D1, D2 bar. This is my D3 wire. Okay. My output Y is D1, D2 bar plus D3. Can you see this wire is coming from D3? So this is how you need to draw the logic diagram. So priority encoder is a very important topic. You have multiple inputs. You have multiple inputs and 2 outputs. 2 by n inputs, n outputs. You need to assign priority to the inputs. In priority encoder, at any point of time, more than one input can be high. Always you need to give priority to the highest one. Okay, so this is how you need to design the truth table, then obtain the logic expression for X and Y, and finally draw the logic diagram. Thank you.